This is Mark, and I'm delighted to talk to you about WonderWindow. Our vision is to make net zero energy buildings affordable and commonplace. And we're going to do that by a fairly straightforward approach to increasing the energy efficiency of windows and building envelopes generally. Windows are the weakest link in the building envelope. On the right is one of our early prototypes that was 4 layers of glazing, 3 insulating air spaces, and it's just by using multiple insulating air spaces that we're improving the overall efficiency. Another major culprit in the building envelope is 2x4 framing that's only 16 inches on center. This is the dominant approach to the way most buildings, not just homes, but light commercial, office, hotel, all kinds of buildings end up getting built 2x4 framing, 16 inches on center. And the problem here is we only have 3.5 inches of wall depth for insulation. And we end up, by the time we end up with headers and jack studs, we end up with the equivalent of having a stud every lineal foot that's radiating heat on average, in addition to the ridiculous expense of it all. For each window opening, we get 8 square feet of excess framing in the headers and the jack studs, etc., for every 13 square feet of window glazing area. And that's where our structural windows come into play, because the fixed top sash can eliminate the headers and jack studs and other excess framing. On the left here you see an informal test that we've done to date showing that this small sample that you see on the right that's only 1.5 inches thick can carry 640 pounds a lineal foot, which in and of itself begins to be equivalent to roof loads. Imagine what happens when we put that window between 2 2x6 studs and in some cases have other additional glazing layers. So we expect that we'll be able to carry roof and floor loads, maybe multiple floor loads, and we will supplement the informal testing that you see on the left with very rigorous testing that follows ASTM D6815, which will yield us both flexural capacity testing and duration of load testing. But beyond those technical factors, what we end up with is a product that you see in both pictures, one where there's a daylighting transom that's fixed above a vision window. Now that vision window can be fixed, but it can also be operable. It can provide egress, 22 inches width of egress and 5.7 minimum square feet that's required by code in order to meet emergency egress requirements. And what also happens, and you see this a lot in the photo here at the left, is that when our windows get to be, when we no longer have a big header up above the traditional window that you see in the background, and the window instead can go all the way to the ceiling, we increase the daylight perimeter. Daylight can bounce into our buildings an extra 3 feet. What's interesting about this 22.5 inch width to the window is it fits 2x6 24 inch on center framing. So that gives us greater depth for insulation and fewer studs overall to be radiating heating and cooling. Now the windows themselves offer 1.5 to 2 times the thermal resistance of traditional windows. And we've tested this. We've done simulations using Lawrence Berkeley Labs Windows and Therm calculation tools, software tools, the ones widely recognized in the industry. And this is an example in 6 glazing layers. Our top sash here develops an R7, a thermal resistance of R7. And our vision window at 4 glazing layers averages to an R value or thermal resistance value of 5. So that's 1.5 to 2 times what current state-of-the-art windows are providing. And this early prototype is showing how we can get operable sash that closes very tightly with a gasket when it comes up against a gasket against this outside trim, and how the outside, the exterior, can be trimmed out in typical PVC framing, so it's going to be durable and waterproof. We've done some informal testing. The one that's shown here is our forced heating test. We managed to take this sample, lay it out horizontally in full sunlight with a black backing very tightly up against the inside pane. We managed to hit 170 degrees Fahrenheit, something that you should never do within your own home. And when we actually forced it, or office, when we actually forced this heating, we did get some moisture being driven out or some vapors being driven out, maybe from the wood inside, maybe from the adhesive inside. But what was interesting is that within 8 minutes over here, once it was taken out of the direct sunlight, so like you see here, it had all the fogging that you see on the left had disappeared just within 8 minutes. We'll talk more about condensation resistance in a second, but we've also done some interesting anecdotal and informal testing for water resistance. We've taken a sample like you see here, submerged it in water fully for up to 30 minutes, actually even several hours, and have seen no water intrusion in those samples. So that's very encouraging. Obviously, these are informal tests. These need to get backed up by the proper National Fenestration Rating Council tests done by independent third parties and the AAMA 101 National Fenestration Standard testing for air, water, and structural resistance, which we'll all do in good time. But we had our initial experience installing retrofits at scale last summer. We managed to get 250 window retrofits installed in Burlington, Vermont. We also have had a window retrofit installed in York, Pennsylvania for several years. This one has gotten down to -5 degrees Fahrenheit without showing any fogging whatsoever on the pane. What you see here is just the protective layer that needs to get peeled off in operation. With our 250 windows in Vermont, last winter in the Burlington area, it went down to -15 degrees below 0 Fahrenheit, and we received no reports then of any fogging or condensation between the panes. Our retrofits work particularly well for aluminum frame windows. We have identified that this will be a very important niche market, and this shows the typical aluminum frame, very ubiquitous on so many different kinds of buildings throughout our country, and the way that we will retrofit it, where we insulate the frame in the process of adding multiple layers of glazing. So we can get a 240 to 300% performance boost in the thermal resistance of the window, and our paybacks look attractive for long-term owners. Folks like the General Services Administration the American federal government landlord, if you will, are very interested in seeing how our retrofits can apply to their buildings. And certainly they're an opportunity to take this to scale rather quickly. Our daylighting transoms also have an application in retrofit situations. Here you see our initial design for the daylighting transom, and you see the seasonal solar shading that we're getting, where we're getting complete shading on the inside here. This can be retrofitted to existing windows or incorporated in our new construction windows. And what we get is seasonal solar control. In summer, we get solar shading. In the wintertime, we can get winter passive solar gain, which will help heat the building. All year round, we're going to get daylight diffusion, with daylight being bounced off the ceiling to go farther into the space, and provide a very wonderful luminous environment. We essentially get to the idea of daylighting art. Here's our initial design that we have actually fabricated, and several other designs in process where we hope to get essentially tunable facades, facade designs or transom designs that can be tuned to the particular orientation in order to provide ideal daylighting. So the sum total of all of these improvements are what is going to yield affordable net zero energy buildings. And quite honestly, we have a target that we believe we can hit of being able to see incorporate our windows into 2x6 24-inch on center framing, and to be able to end up with affordable net zero energy buildings that are coming in at construction costs between $120 and $200 a square foot. That's what we're targeting. We're out to prove it rather quickly, and we'd love to hear from you if you're interested. Email me at mark@wonderwindow.net, and we'll enjoy picking up the discussion. Thanks.